If you want to start a Spring Boot application, you go into Spring Initializer. We're going to go into, you guys are using Maven, right? Or Gradle? Which one do you guys prefer?
We're using Maven.
Okay, we'll do Maven. 3.21, com example, demo. We can keep all of this. We'll use Java 21. For the dependencies, what you want to do is we'll add Lombok. We will add JPA. We're going to add Spring Boot, or Spring Web, I mean. We were not going to add Spring Security yet, but we can do that later. And then what is the other one that we want to add? We want to add H2. We can add H2. And then we want to add our Postgres driver, okay? So we're going to be loading Lombok. This cleans up our code, makes it very easy to write getters. This thing writes getters and setters for you automatically. It writes constructors for you. It does the toString for you. It does really cool stuff. This is Spring Data JPA. Spring Data JPA allows you to build DAOs with like 2 or 3 lines of code. It's super awesome, if depending on your use case. Spring Web, you guys should all be familiar with. This is how you write controller endpoints. And then we have H2 database, which is an in-memory database. So this H2 database thing right here, this is the driver, okay? So this driver talks to an H2 database, which is an in-memory database, which means it doesn't save it for real. It only saves it in memory. Once you restart your application, the database gets destroyed. And then finally, if you want to talk to a Postgres database, you need the Postgres driver here. All right. Any questions so far? Okay, now we're going to go ahead and generate it. When you go ahead and generate, you open this up and it's going to create this demo file folder or zip. You just open that up, copy it, go into your projects folder, and then paste it in there. So here's my Git folder, all of my projects. I'm going to paste it in here. Okay, and then here's the demo. And then when I go back into IntelliJ, let's see, we're going to open. So you're going to open demo here. And then we can go ahead and get started with stuff. Okay. All right.
Can I ask a quick question?
Yes, go for it. Thank you. I love questions.
We use the created database for the GPA. So
yes.
The bottom size H2 and Postgres driver has GDBC using in. So it's gonna be any crash for the using together?
No. And the reason for that is because you're not actually using them together. Oh, wow. Look at this. This is the first time. Wow. I hope this doesn't break. I just took. So when you take it from Spring Initializer, you're pretty much guaranteed that it's going to work because their engineers have put together the right configuration in Maven for you to have like a stable build. So having an error here is very surprising. But to answer your question, no, you don't have to worry about them. The answer is yes and no. But the reason we don't have to worry about it is because when you go to the application properties here, you are going to be able to configure your H2 instance here for like a local environment. And then for the cloud, you can then set up a Postgres configuration. So locally, you can use the H2, but then when you deploy to the cloud, you change the environment. You tell it like, okay, you're in the cloud now. Please use this cloud configuration, and the cloud configuration will be you using Postgres. Does that make sense?
Yeah, it does make sense. Can we using the H2 for the GDBC or GPA as well?
You can use it for both.
Okay, that's good. Thank you.
Yeah. And I don't like properties. I prefer YAML, so that's why I'm changing mine to application YAML. All right. So let's go ahead and what kind of CRUD do you guys want to build? Pizza CRUD? Zealot CRUD? You guys like pizza?
Yeah, pizza's great.
Yeah, let's go to pizza.
Okay. All right. So let's go ahead and create a model here. And we're going to create a new class, and it's going to be a pizza class. And what kind of properties do we want this pizza to have? String, how about enum size? We'll have size, right? Okay, what else do we want to have for this? Oh, that's not it. Let's do pizza size.
List of toppings.
Yeah, okay, cool. Ooh, a list of toppings. That's complicated.
A string
like
of
it.
toppings.
Yeah. Yeah, we're going to create the class in here, and then we're going to do an enum. Are you guys familiar with enums?
No, if you could explain, I really appreciate it.
Yes, okay, cool. So what I'm doing right now is, the heck? What I'm doing right now is I'm creating an enum, and an enum is basically it's specific values that you're making a whole new data type, but the data type can only have these values. All right. So in this case, if you guys remember from Tech Elevator, usually they have this as an int, right? And then they have like a static int, like small is equal to 0. Do you guys remember this? And then
Yeah.
static, and then if you want to make the size equal to something, you make it int small like this, right? I mean, this is nice, but the better way of doing this is using an enum. And so instead of making constants for all of that, you're just going to make the values in here of small, medium, large, extra large. And so inside of your pizza, you're going to have a size of pizza size like this. So I'm going to create a sandbox package. So I'm going to run stuff real quick. And I'm going to put a Java class sandbox. So in here, I'm going to do a PVSM, PSVM, all right? And then I'm going to do pizza is equal to new pizza, like that, all right? And then I think I made it private, so okay. So I made that field private, so pizza dot, you don't have any access to it, right? So for this, I have to make a getter and setter, right? So let me just generate. I'm going to generate a getter and setter for this, okay? And so now I have get size, pizza slice, or pizza size, and then I would have set size, and it's just getter and setter. And so in here now, I'm going to do sout pizza dot get size, okay? And then I'm going to set the size. So I'm going to do set size, and then this is what's cool right here. When I set the size and I highlight this, it says, let's see here. The IntelliSense should tell me it's expecting a pizza size, okay? So I'm going to then type in pizza size, and then I'm going to hit dot, and now I have access to those values. So if I want to have medium pizza, then I'll just set it to medium pizza like this, and then I'll go ahead and I'll print out what's in there. Pizza dot get size, okay? And if I print this out, I think it's going to print out a number, and I'll explain that in a little bit. But what I want to do is I want to print out the name. And so when you run this, you're going to see that it's a medium pizza. So let's go ahead and run this real quick. Let me know if I'm going too fast. Okay. So here, we first print out pizza.getSize at the beginning, and we get null because there's nothing in there. Then we set the size to pizza size.medium, and then when we print out pizza.getSize.name, we see that it is medium. It's pretty cool, right?
Yes.
Now let's go ahead and take this out. I'm just going to print get size. I forget, it's different with different languages. I think it's going to print a number, but it might print out medium. Let's see what happens. So when I run this, I think it should print out 1. Oh, it still prints out medium. Great. Cool. So we're good to go on this. Now, the way this works in Java is this pizza size, these enums are actually numbers underneath, okay? So small in this case is 0, medium is 1, large is 2, and extra large is 3, okay? So This could be an issue if you try to save this to the database, okay? Because the database might save it as numbers, and there's an argument over that. People are, because when you're only saving numbers, you're taking up less space than the string, right? So some DB admins might actually want that. They might actually, I mean, they might like that. So there's no right or wrong answer in this case, okay? I prefer to save the names because when somebody's looking at the database, they actually understand what they're seeing. But if you have a billion of these records, then that's a lot of extra space there, right? So that's why it's give or take. You don't know, or you don't know. It's debatable. That's why there is no right answer.
There
Does
is
that make sense?
there is actually an annotation you can use.
Yeah. Yes. Good
It's
job.
called enumerated, and then you can
Yes.
say it's an enum.type string, and then it'll
Yeah.
store it as a string value.
That is awesome. Thank you so much. Cool. So we could talk about that later. So that's JSON parsing. So we could talk about that in a little bit, Chris. Okay. So now that we have all of this, let's talk about some other stuff here. So we have our, and are you guys all familiar with Lombok yet? I'm going back and forth, so just ask me questions on the. I'm like all over the place, so please ask me questions. Yeah, you guys are saying you want toppings too, right? Let's do private string toppings, or how about? Yeah, we can do toppings.
Why would you use an enum for toppings too?
Well, we could. The issue is that when we're thinking about databases, let's do that. Let's talk. Let's set up the database first. We can then I can then show you what it looks like behind the scenes in the database, and then from there we'll try to add a list of toppings, because that would be that would be interesting to try to approach that. So now that we have this, right, let me just show you Lombok real quick. So in here, we're going to do Lombok. And before we do that, when you're using Lombok, you want to set up your annotations. So you want to enable the annotations. And the way to do that is you go to File, Project Structures, Project Structure, and then all you got to do is, oh, I think it's File Settings. Go to File, Settings, and then here look up Annotation. And you're going to see annotation processors here. And then all you got to do is enable an annotation processing. So what this does, this is a special thing that you have to do. You have to remember this all the time. If you try to use IntelliJ or if you try to use Lombok on a project in IntelliJ that does not have this enabled, the IntelliJ is not going to generate the code for you. Okay, which will give you these weird errors. So just remember, if you're using Lombok, you have to enable annotation processing. All right, it's a pain, but Lombok is so useful, it's totally worth the pain. So with Pizza, instead of having to generate all of these fields, anybody, what other fields can we use? Private string, what else can we use with the string?
Sauce?
Sauce? What are the options for that? How about
I mean, some people like barbecue, some people like tomato sauce. There's always a heavier marinara. I'm just gonna stop.
All right, let's just put sauce there.
Pesto.
Let's keep it as a
Pesto
string.
sauce.
Let's keep it as a string though. What? Because you could make the argument that you can make it an enum also. What else is there?
You could have a name for the pizza, like if it's a menu item.
Oh yeah, cool. Yeah, good. Menu name or display name. All right, cool. Anything else?
How about crust?
Yes. Private string crust, or yeah, let's make string crust, and then we'll have a boolean in here too, just to have one. Boolean, and what's a good Boolean value for a pizza?
Well done.
Cheese.
Well done.
Cheese too, yeah.
Well, cheese, you would just have your ingredients.
Tasty maybe?
Gluten-free.
Is deep dish? Or is that
Stuffed
crust?
crust. Stuffed crust.
That's crust.
Hmm.
Stuffed crust. I'm completely messing this up. It's stuffed crust. Let's just keep that.
This crust. I just had that
Okay.
the other night.
This doesn't really, like, the actual pizza itself doesn't really matter. Like, I just want to show you the technical stuff. All right, so we have a pizza, a string, and we have a Boolean. And okay, so we have our model here, right? So we would have to generate all of these, we would have to generate all these getters and setters, right? And so when you do that, and you go through all of these here and you hit OK, you end up with this very ugly looking, I mean, it's just, there's just so much code here, right? And you start ignoring this stuff. So what Lombok allows you to do is it allows you to generate the getters and setters, but also hide them. So I'm going to delete all of these now. And because I have Lombok set up, I'm going to use the @data annotation. Okay. And what @data allows you to do, doesn't show you here. Let's go back to Lombok and see what it does. So I'm going to do Lombok @data. And so when you click on @data here, it's going to explain to you what it does. @data is a convenient shortcut annotation that bundles the features of toString, equals and hashCode, getter, setter, and required args constructor together. In other words, data generates all the boilerplate that is necessary, that is normally associated with simple POJOs and beans. Getters for all fields, setters for all non-final fields, and appropriate toString, equals, and hashCode implementation. All right, so this is really, really cool. And I'll show you what I mean by that. So now that we have @data here, so let me take off @data here. And I go back to sandbox here. I'm going to now see how I have this get, set, and get all turn red. It's because I deleted all the getters and setters. And I also don't have any access to those properties anymore because they're all private. So I don't have access to the fields. All right. And so when I go here and I type in @data, I will now generate all of the code for these fields. So when I go back to Pizza's sandbox, you're going to see automatically that the getters were set up properly. The getters and setters are set up properly. And now when I do pizza dot, you're going to see that I have set size, get crust, get display name, get sauce, is stuffed crust, set display name, set sauce, set stuffed crust, and so on and so forth. Pretty cool, right?
Yes, so you are saying if we are using the data, we are not anymore the add, setter, and getter.
No,
right?
you don't have to do any of that. This is how clean it looks. It looks awesome.
Okay, good to know. Thank you.
And so now that you've done this, right? Check it also. So let's go back to what it does. So data is a convenient shortcut annotation that bundles the features of toString, equals, and hash, getter, setter, and required args constructor. So what does that mean? That means I'm going to put this in here so we can cover this. Okay. Data is a convenient shortcut that does the features of toString, equals, hash, getter, and setter, and required args constructor. So now that you have this, let's see what the toString does. Okay. So I'm going to take this off, right? And let's just go ahead and generate all the getters and setters. So I'm generating all the getters and setters. So I'm not using Lombok, okay? Because I want to show you something. We're going to talk about toString and what it does. So if I go back to the sandbox, I'm going to do sout pizza at the very end. So I'm going to sout pizza, and then I'm going to run it. Run it. Oh, it already ran. Cool. So when you run it right here, you get the name of the class, com example demo models pizza, and then you get its hash code at 169.8C449. The hash code is a special number that identifies the instance. Okay. So this is really not that helpful to me, right? But with Lombok, if I go to pizza here and I put a toString here, like this, if I put a toString on this pizza, when I rerun this code, it's not going to have this gibberish. It's actually going to show me what's inside of the pizza. So it automatically sets up pizza, size equals medium, sauce is null, display name is null, crust is null, and is stuff crust is false. Is that cool? You guys like that?
I love it.
Really
Yes.
cool.
That's like super cool.
Yeah, it is. It's nice. And then so equals and hashCode, I'll explain this later. The getters and setters, we already saw that. And now let's do required args constructor, which is, it's also very smart with this. So we have our pizza here. Remember in Java, so yeah, okay. So in Java, every class has a empty constructor here, okay? But if I do this, all args constructor like this, then what this does is it creates a constructor for all of the properties that are not final, okay? So that means I'm just gonna put final on this, which means it's a constant now. If I put final here, it'll create a constructor for all of these non-final properties. So when I go back here to sandbox, oh, it's because I didn't set the value. Let me just set the value equal to null so it doesn't complain. Oh, what is it not like? Oh, I can't set it because it's final. All right. Okay, so now that we have all this, right, I'm going to go back into sandbox, and you're going to see that this constructor requires these parameters of pizza size, string, pizza size, sauce, crust, and is stuffed crust. So we would actually have to populate those values in here. So pizza size dot small. The next one's going to be sauce. So what did you guys say? Marinara? I don't know if I spelled that right. Probably not. Crust is going to be thin crust, and then we'll have it be stuffed crust as well. So we're creating a pizza here with this special constructor, but notice how so Lombok still follows the rules of Java. So remember in Java, if you try to, as soon as you create another constructor, right? If you create another constructor, the empty constructor disappears. It doesn't exist anymore. So by us putting at all args constructor here, the empty constructor doesn't work here anymore. Okay. So when I go back here and yeah, I said, so if I want to show you what I mean by that. So if I go pizza is equal to new pizza, you're going to see that it doesn't exist because that constructor does not exist anymore. Does this make sense? If you have any questions, please. Am I going too fast?
No, you are good. I'm curious about the entity.
Okay, cool. All right. So now that are you talking about the annotation entity?
I don't know. I just using it in my code.
Oh,
Some
okay.
guys using,
Yeah,
so
yeah,
I
yeah,
don't-
yeah, yeah. I will explain that in a little bit too. Okay. So, but that's different. That's not Lombok. At entity is not Lombok. It's Spring Boot, and it's Hibernate. So Hibernate is the framework that lets you map a Java object into a database. We'll explain that. I'll explain that in a little bit. Okay, so where was I? Okay, so yeah, this whole constructor. So the required args, this all args constructor allows you to create a new constructor, right? That lets you put in all your values here, and then also I can do this pizza, or I can do pizza empty pizza is equal to new pizza, and I'm going to have no constructor here, right? So that's why it's giving me an error. But if I go back to pizza here, I can actually add a no args constructor like this. So by me putting at no args constructor, I'm telling Lombok, please create two constructors for me. One constructor for all of the properties and another constructor with no parameters. And so when I go back to sandbox, this thing now is happy. Okay. Any questions? Okay. The next one is equals and hash code. All right, so we covered this one right here. We already covered the getters and setters. So the next one is this. This is super important. Very, very important. So at equals and hash code, if you generate it from IntelliJ, which I highly recommend you go through and you and do that so that you can see it for yourself. I'm going to generate the equals and hash code here. And let's do it for all of the members. And I'm going to hit next and hit next. Select all non-null. Oh, wait up. Let me cancel this. So check this out. If I go back and I take off this final here, all right, what do you think will happen if I take off this final? As far as the constructor is concerned. So this is where Lombok gets a little weird. Because and it's kind of cool, kind of not cool. It's kind of cool because it automatically generates code for you no matter what. Okay. So if I take final here and I delete it, that means it is now a non-final field, which means this all args constructor will now generate a constructor for all 5 of these fields. Okay. So when I go back to sandbox, it's going to get mad at me because this constructor only has 4 parameters. Does that make sense?
Yeah, makes sense.
So now here, I just got to put the display name. What do I call this? Italian? I don't even know what I'm doing. I don't know pizzas, guys. Sorry. So we'll put Italian. It's like so stupid. Yeah, they're all Italian, but we'll put that right. And so now that you have that extra parameter, so now because you made this non-final, right, and it's now one of the 5 fields. When you add the all args constructor, it automatically adjusts for all 5. This is a pain when you have a bunch of tests, right? And you have your like 10 fields, and then you're like, oh, I'm going to add another field, and then you're using the constructor for everything else. It like there's red all over because you're going to have to add an extra field or an extra parameter in all of your constructors. So this is when you're refactoring. This is where Lombok can be a pain. There is a way around that, and I can also show you that. Let me show you anyways. So no, let's keep on going here. Okay, so now that we have all of this, right? Let's go ahead. We already got the getters and setters. Let's actually add the getters and setters here so that we can just get rid of all the other code. So at getter and then at setter. So notice how I'm adding all these at the top, right? We don't need these anymore because we're setting all of them for each individual property automatically. So when we go back to sandbox, the code still is happy because now we're doing, you can still see that the getters and setters are good. Get size, set size. All right, and then finally, let's do the equals hash. Okay, so we're going to generate this. We're going to generate the equals and hash code, and yeah, we're good here. Good. Select all non-null fields. Oh, these are the ones that can't be null. So we're gonna make them. We'll make it so they're all null. Okay, so this is so when do you use the equals and the hash code? Okay, so this is a kind of like a deep dive. So remember, if I have an empty pizza here, let's do this. Let's do pizza 2 here. And I'm going to make it equal to the exact same thing as this pizza. Okay, same exact values. All right. And I'm going to do s out pizza equal pizza 2. And this should hopefully be false. It should be false. And then I'm going to do pizza dot equals pizza 2. All right. And let's do dot equals. And what aren't you liking about this? What?
Probably just do parentheses around the boolean.
Yeah. Thank you. Cool. All right. So now that we have this, let me go back and take out the code here to show you what it looks like without Lombok, or without, I want to show you the default behavior for equals in hashCode. All right, so let's go back here, and then now we're gonna, let's actually print out the hash codes. So I'm gonna print out hashCode for pizza, and let's print out pizza dot get pizza hashCode. All right, notice how hashCode is an int. All right, but hashcode's a number, but when you try to print out pizza, remember how it had all that weird gibberish, the numbers? That's in hexadecimal, okay? So that hexadecimal value is the exact same numerical value as the integer that gets returned. So just don't get confused by that. If not, we can figure out how to print out in hexadecimal. I just don't remember how to do it right now. So hashCode, and then we're gonna do pizza2 dot hashCode. Okay, so these numbers should be different. Let's go ahead and run this. So I said, so pizza is one object and pizza2 is another object, okay? Pizza has the value of small, marinara, Italian, thin, and true, and pizza2 also has the same values, okay? So even though they are, the values of are the same for both pizzas, they are still separate objects in memory, okay? So pizza has its own memory address, and pizza2 has its own memory address, okay? So when I use the equal operator, I should be getting false, because what I'm comparing here are the memory addresses. When I say, is pizza equal to pizza2, I am actually saying, are these different, or are these the same memory address? Okay, so if I do this, s out equal operator on same object, and I do pizza equal pizza like this, this should be true because it's the same memory address. But then this one should be false because these are two separate memory addresses. So let's go ahead and run that again. And you see here, equal operator on same object is true. And then equal operator on the different objects are false. And then when I do dot equals, I also get false. All right. So the default behavior of dot equals, is to act like an equals. Okay. So the default behavior for dot equals in Java is to act like an equals. All right. You can then modify the dot equals to do value-based comparison. What does value-based comparison mean? Value-based comparison means I am not comparing the memory addresses. I'm comparing them based on the values inside of it. Okay. So like, for instance, yeah. So if we want to say, like, if I want to see if this pizza matches this pizza, I would want to override the add equals to compare everything by value. All right. And so the way to do that is IntelliJ has this amazing feature for you where you just go right click and you generate the equals in hashCode. And no, by the way, notice that the hash codes are different, right? Hash codes are different. So I'm going to do generate, and I'm going to do generate equal. And I'm going to create it. And so let's look at this code, what it generated for us. So remember how I said before the equals does memory-based or memory address-based comparison. It says this object has the same memory address as another object. But the equals here is value. So when you override or you have IntelliJ and generate the equals method for you, you're making it so that you compare everything by value. And let's check out this code. So when I go in here and I do pizza equals pizza2, so let me go back here and just put this in. There you go. So when I do pizza dot equals pizza2, right? This in the code is equal to pizza, and the pizza2, because I'm passing in as a parameter, is inside of this object O. Okay. All right. So when I do pizza equals pizza 2, pizza is into this, which is this guy right here. And then pizza 2, because it's the parameter, it's now the O. So first thing first, look, we check, is this thing even the same object? So they use equals here. They say, is the object, is my object have the same memory address as O? Because if they did have the same memory address, they're obviously the same object. So if they are, then it just returns true and it kicks you out. It says that this thing, they're both equal. If they don't have the same memory address, we then make another check. We then see, is O equal to null? So this is kind of it. The fact that you can even call dot equals on pizza means that pizza is not null. There is definitely an object in pizza because you can actually call equals. If pizza was null, then you couldn't even call dot equals because you can't call methods from null values. You'll get a null pointer exception. So if O is null, we automatically know, oh, these objects are not the same because there's nothing in O. So if O is null, we return false. Okay. If O is not null, notice how it's object, by the way, right? Object is the highest class in Java. Everything inherits from object. So we don't even care what kind of object. You can use any object in here. You can use like integer or long or like string. Like it doesn't matter. You can pass in whatever object you want, and Java will accept this. But what we do want to do is we want to check, is the class equal to so is the class from pizza equal to the O class? And so that's what this line of code. So if I pass in the string, O is a class of string. It is not a class of pizza. It'll return false. Okay, so if they are both pizzas, okay, we're good. We can now bypass. We don't have to return false. We keep on going with the code. Okay, so this is where we use typecasting now. We take a pizza and we now convert the O, because we know that O has the same class as pizza, right? So because we know that O has the same class as pizza after this line of code, we then convert it to a pizza and we put it inside of its own variable. Okay, so now we have pizza. We have O identified as or put inside of the pizza variable. All right, and so now what we want to do is we want to compare, is our stuffed crust the same as the pizza stuffed crust? And you just go down the whole line and you go, if this is true, and the size is equal to the pizza size, and the sauce is equal to the pizza sauce, and the display name is equal to the display name of the pizza, and the crust is the same as the pizza crust. If they are all the same, we're going to return true. But if one of these things don't match, we are going to return false. Okay? Whew. So all of that code allows you to do value-based comparison. So let's go back to the code and I'll show you what I mean by that. Because pizza 2 has all the same values as pizza 1, now this thing, this code right here should now, see how it's false? Now it should be true when we run it. So we're going to go ahead and run it. And you could see, wait, what? How is it false? That's hilarious. Did I get something wrong here? Is stuffed crust equals? Yeah. Am I missing something? Pizza dot equals pizza 2. This is awesome. Let's see what the heck's going on here. So I'm going to debug this. Okay, and I'm going to step over. Let's go all the way down to equals. All right, now we're going to step into this. Okay, so we are here now. And we're going to go through the first line of code. So we have, let's look at this here. So we have our two pizzas here, right? The first pizza is size medium with marinara sauce, Italian, thin, and true. And then pizza 2 is small, marinara, Italian, thin, and true.
Why is it small instead of medium?
Oh, this one says small?
That one says
We
medium on
set the
top.
size after we initialized both of them, if you recall.
Oh, thank you guys. This is why we pair program. All right. That's awesome. Yes, let's take this out. Good. That is awesome. Okay, so now when we run this, it should be true. Okay, let's run it again. There we go. So now it's equal to true. And because we changed one of the values to medium, we will then get false. So dot equals true. Now dot equals false. Okay. So that's cool, right? And then, but the thing is, now let's look at the hash code. The hash code for this, that's weird. Why is the hash code like that? The hash, oh, because they're false. So the hash codes are different because they're different values. But when I make them all the same, like this, right? So these are both supposed to be equal. You're going to see that the hash code should match also. And yep, they do. Let me just put a dash here just to make it more readable.
Just call it pizza 1 and pizza 2.
Yeah.
And then a space.
All right, let's do that. I love it when you guys get involved. Okay. Yeah, so you can see that they're the exact same hash code. The negative thing is actually just put the space there. So equals true, both matching hash codes. Why do we care about the hash codes? That's the thing, okay? So in a hash map, let's just do it. So in a hash map, right? Can anybody explain to me how a hash map works? Or can anybody try to, or wants to attempt to explain how a hash map works? And why it's so important?
The hash map is a collection of key value pairs.
Yes, good.
It's unordered, it's very easy to sort by, and it doesn't take up much space.
Let's go. But why is it that you can search so quickly within it? And the same thing with the hash set. Like you can search within the hash set very easily. Or very quickly. Why do you think that's the case?
Well, based on what we know so far, I'm guessing that you can use some binary search because the hashes are sorted.
Isn't it like an instant search because they're each values? It's calculated. Since you can calculate a hash so fast, you can search really quickly because there's only a unique key.
Almost. You guys are close. You guys are close. Very, very good. I don't know about the. I don't think it's a binary search though, Christopher. But the way yeah, it's not a binary search. It's like a bucket search. Okay. So when you think about your dictionary, right, or like an actual dictionary, like Webster's dictionary, if you want to find a word, let's say you want to find the word xylophone, right? You go and look at X. You go to the X section of the dictionary, and then because you're now in the X section, you only have to search that small little section of the book for the actual word. All right. And if I do something like matter, right? I want to look up the word matter. I don't have to go through the entire book searching for that word. I go to the M section of the book, open it up, and then I can then look to see, oh, okay, there's an M here. Then I go to the McDonald's section. So that's why it's sped up very quickly. Okay. With the hash code, and this is a very simple example. Like there's multiple buckets, like 30 to 250 buckets or whatever. So when I say bucket, I just mean like a section of data. So like our dictionary has 26 buckets, a bucket for each letter. Okay. And as a simple example, let's say there's 10 buckets with a hash map. You'll have your 0 bucket, your 1 bucket, your 2 bucket, your 3 bucket, 4 bucket, 5 bucket, 6 bucket, 7 bucket, 8 bucket, 9 bucket, And there it is. And so what happens is based on the hash code, it'll then put so it has 10 buckets and they're all lists, right? And so in your hash map, if you have a hash code of 124, then let's put that hash code inside of our one bucket of 124.176.7434. Okay. And then let's say I have another hash code of 300 or of 3 million or whatever. So I'm going to put this big long number here, right? And so let's say I have another one. And so as you keep on doing this over and over again, if you want to search for a specific item, you get the hash code. So this is what you're saying, Andrew, about how you can calculate it very quickly. So the hash code is basically a number that you can calculate to quickly identify your object. And then from here, you then look through these lists of lists. You go through the list of lists to your particular section. So if it starts with the 5, you go to 5, and then you just go down the list of that. You just go down that list to then see if that object is in there or not. Okay, so you can now imagine this with millions of records, right? So let's say you have 1, 2, 4, and like you have this one here, and then we have another one here, right? And then you have this guy here with the 3, and we'll have another 3 here. We'll have another 3 here, and so on and so forth. But this thing is just evenly distributed, right? Like if it's evenly distributed, then that means you don't have to search through all, million records. Let's say there's 10 million and there's 10 buckets. Instead of searching through all 10 million records, you only search through 1 million records. So it cuts it down by like a tenth. If you have 200 buckets, right, then that cuts that search down to a 200th. So it's awesome. Does that make sense? Yes, no?
Yes.
Anybody else? Does anybody else need another explanation, or do you think you're good?
I think I'm okay.
So, I mean, yeah, okay. And even if you don't get it, it's okay. It's something that you can discuss during an interview, but I really haven't even seen this interview question.
Can you go back to
but-
that code for the hash, the generated code you did for hash that it did?
Yeah.
What does it look like? Because that's how. Oh, it's just basically.
It's just it's a Java method called hash, and then you just pass in the parameters, and then it automatically tries to hash it for you.
Oh, I see. So you could do that pretty much for any set of values, I guess, and get
Yep.
a hash value.
Yep.
Oh, okay.
So in here now you have all. So that's how. So I guess what it comes down to is, you don't have to understand completely how it works. If you don't understand it, it's okay. But what you need to understand is hash code is very important for the hash map and the hash set. And if you do not have the hash code operating correctly, then your hash map and your hash set is not going to work properly, because you're not going to be able to use this algorithm properly.
Do you often see in like enterprise people use hash maps in their searches of things?
Yes, I would say it depending on where you are. If you're like a junior developer, probably not.
Where they use
but
instead?
They don't even have a need for them. There's like, for whatever reason, I mean, when you look at a controller, you look at like a DAO, you really don't need maps for that. It's more advanced stuff. But yes, the more advanced algorithms, you're definitely gonna need a map. A map's amazing. So is a set. You can do really cool stuff with them. So
Cool.
Okay. All right, so I think we're good here. So if even if you don't get this, or just know that a hash code is super important. You got to understand how the hash code is being generated. So let's go back and do this. So because typically what happens with the hash code is it is random. So let me see if I can generate a random one. Let me get rid of this, and let me get rid of this equals. And I'm going to generate a random hash code. Let's see how it works. So I'm going to not use any of these. Let's see what, oh, it's not going to let me. This is all, okay, so IntelliJ is assuming that I want to have some sort of value-based comparison. So check this out. This is where it gets a little crazy here, right? If I want to do everything by display name only, right? I can make an equals and hash code specifically to the display name of the object, all right? Like this. And so now, if I change everything else, so if I make this false, and I make this large, right? And I run this. This is not intuitive. I don't really recommend you do this. So notice here that the display name, because they're the same, it is still showing that both objects are equal. And that they're both showing the same hash code. All right. This is not cool. I do not like this. I mean, you should not like this either. It's not intuitive. The first pizza is large. The second pizza is small. But because we set up our equals and hash code to only check the display name is the only important thing at this point. Does that make sense?
Yeah.
Yeah. So let's go back to this. So I'm going to erase all this. So remember, look, I'm only comparing the display name and the display name here for the hash. Also notice that the hash code uses the same fields that the equals method is using. All right, because you want to generate the hash. However you're doing your comparison between objects, you want to be able to create a hash using that same logic. So here you're identifying every object based on their specific properties. So whatever those unique properties are supposed to be, then you want to also include those in the hash code so that there's differences in the hash code so that the hash map and the hash set can properly identify them within the code. Okay. So all of that talk, right? Like we did all the equals in the hash code. So I'm going to take this out. And now what I'm going to do is I am now going to add equals and hash code. And this is the final leg of the data annotation. So the data annotation does not include the no args, right? So it's toString, all args, getter, setter, equals and hash code. And so when I run this code, it's still going to be true because this equals and hash code is evaluating all of the fields. So when I go ahead and run this, oh my gosh, I get proven wrong. Oh no, I didn't. Hold up, it's because they're different. It's because they're different. So I was actually kind of proven right. I just forgot that I changed these. So let's go back and do that. And so now it should be true. So Lombok does all this cool stuff for you. And so you see they're true, and now the hash codes are the same.
Wow.
So now that we've proven all of that, let's go back to pizza and let's take out all of this stuff right here and then just put at data. And as soon as we put at data, the one annotation does all of that magic for you. So now that we have all this, we're going to run it and it's going to be true. And you're still going to get the same hash codes.
All args constructor is not included.
Oh,
in data.
yeah. Thank you. Thank you. I thought it, doesn't it say that it's included in there?
Required args constructor.
Oh, required args. Ah, shoot. I covered the wrong one. So required args constructor is this. If I make all of these a final, then you require a constructor because these have to be initialized. Okay. So if I do this like this, right? If all of these have to be initialized, then when you run this, it'll automatically create a constructor with 5 different values. So let's go ahead and rerun this. I think I can't. I have getters and setters here too, right?
Well, you initialize display name, so it's not going to be all 5.
Oh yeah, cool. So the reason this is not working is because you can't initialize it more than once. Because once you initialize it once, you can't do it anymore, else you'll get an error. And so you can't create a constructor that initializes all 5 because I already initialized it here. So let me just take this out. And then when I rerun this, it should now break if I'm trying to set anything. Nope, I'm not trying to set anything. So we're going to run this again. And so the constructor's happy now. Okay. But typically, if you want to have a POJO that you can get and set, these are not going to be final. Okay. So let me take these out. And then this is where it becomes helpful to add in the all args constructor. All right. So when you do at all args constructor, it'll then create a constructor for all of these private fields that have getters and setters. That's the important thing, setters. Okay. So any field that's not final, the all args constructor will generate it for you. All right. And so let's go back here and you'll see that it did generate it. Any questions? I apologize for that mistake. So there's an all args constructor, there's a no args constructor, and there is a required args constructor. The required args constructor is the one for the final elements. Field, I mean. And so, yeah, we can do this. Well, let's just do this. So we can do private, final. What else is there that we can put? Any ideas that we can put for final on this? Has discount, I guess. I don't know. So final Boolean has discount. So you can only set the has discount once. Yeah, has discount might not have been initialized. We get that. But we also have a required args constructor.
I think it's not jiving with the all args constructor now.
No, it should. I guess we can do yes. Maybe, okay, let's set that up in here and then see if there's a required args constructor there. So we're going to do pizza 3. And let's see how many arg constructors we have. So we have 1, no parameters, no parameters. That's so weird though, because I've seen this work. Yeah, maybe it is not maybe it is getting messed up by this. Let me see if I put this first to see what happens. I don't think. Well, I mean, this is me just playing around. I haven't actually. I don't think I've actually seen required and all args together. So I don't even think you guys should even really. This shouldn't mess with you guys. Like, yeah, I don't think you guys are going to see this in the field. Huh. Okay, I'll take it out. But that's what required arg. Required args is basically for the ones that are final. I'm sure there's a way we can set it up, but we'll leave that out. All right. So no args constructor is an empty constructor. All args constructor, or maybe. Oh, I know why. Because we had a no args constructor. So okay, that makes sense. Lombok is too smart for me. So it's basically saying, look, you have a no args constructor. Like this means that this is not going to get initialized, right? And so, and Chris, like you were saying, this thing has an all args constructor, which means that all of these get pop. These guys are, you're going to create an object with all of these that are initialized with the all args constructor, but the required is not. This guy's not going to get set up either. Well, let's see. Let's take out the no args. Oh yeah, cool. So that works. So the all args constructor is smart enough to set up a constructor for all 6, and then a required args constructor will make sure that it sets up this one discount. So when I go back here to sandbox, it's going to complain about this, right? So this is where I put in the first value. So I'm just going to put value here. And yeah, it has discount value. And then for the other constructor, yeah, see how it has discount, has hello here? Are you guys cool with this?
Yeah, you're using one constructor versus the other one.
It's Lombok has specific logic in how to create the constructors, and required args constructor means that this final has to be initialized. So this guy has to be initialized no matter what. So if you're going to create constructors, you need constructors that have to initialize this guy. And so if I make a no args constructor like this,
Yeah, you
it
can't have that.
breaks. Yeah, you can't have it because you now have a constructor that doesn't initialize this guy.
Right.
All right, cool. You might see this, you might not see this, but it's always good to understand how to use constructor annotations. Okay, so let's get out of this one. You're typically going to see the all args constructor for Pojos. So let's go back to sandbox. Let's get rid of all this stuff. Okay. And let's add the no args constructor back. All right, cool. And let's take this out. Okay, so now that we have all that, this guy is happy. This guy is not happy. Yep, he's happy now. There you go. Okay, so now that we have all of this, why are you not happy? You should be happy. There you go. Okay, so now that we have all of this here, right? You guys, yeah, I think we've covered pretty much everything. There's one more thing I want to cover. So the next thing you want to cover, let's take out these constructors. So there's a, yeah, look at this. Notice how this thing broke because now my constructors are gone for that. So what you want to do is you're going to do an at builder. Well, I'm going to show you an at builder annotation. And what the at builder annotation does is it allows you, instead of using a constructor, you use a builder design pattern. So let's see, I want to show you how it works. So you're going to go pizza dot builder, and then now I can do dot size, pizza size dot small, dot sauce, marinara, dot display name, Italian, dot, what was the other one, crust, thin, dot is stuffed crust, true. And then once I'm done with all of the options, I can then do build. Okay, so now that you have, if you're using this, you can now even break it down like this if you want to make it look a little bit cleaner. And so this allows you to use a builder class to then make it. So who care? Why do I care about this and this? You might arguably say that the pizza constructor or the full args constructor is better than the builder, and I would agree with you, except when you refactor. So I'll show you that in a little bit. So first of all, as part of the builder class, let me go ahead and add the all args constructor. And I think a builder class, as soon as I add an all args, oh yeah, let me add the no args for that one. Let's just take this out. Okay, so we have an all args constructor and we have a builder annotation. And we can now build different pizzas. So I'm going to do pizza 3 is equal to this, right? So this is nice. This looks a little bit clunky, right? The constructor is one line, so you can arguably say, yeah, I kind of like the constructor better. The problem is that when you add an extra field, let's say we're going to add private string label. I'm just making stuff up here. Now that I add label here, this all args constructor regenerates the constructor for all 6 of these fields. And so when I go back here, this is now broken. So now I have to go back and put a label inside of these constructors here, right? So that everything works properly. But notice the builder though. the builder is dynamic. It's not it's not based on the number of parameters, right? It's not fixed. It doesn't have a fixed number of parameters. Nothing broke with it, because even though you added the extra label, you don't require it to actually build the object. So that means you don't have to redo all of your tests. But then again, the argument is like, well, why wouldn't you want to do all your tests? Like, this label might be super important. Like, why would you want to make it so that you could just keep your objects from breaking? Like, that could promote laziness so that you don't update your test. Do you guys get what I'm saying, or am I going too far down the rabbit hole here?
No, that's a good point. I was gonna say that. Why would you want to update a constructor and then allow your test not to be updated?
Yeah, exactly.
So that doesn't make sense. I mean,
Yeah, there's some tests where you're really only like if you're checking database stuff, right? Like you don't care about a lot of the fields. You just care that the IDs and stuff are matching. So
yeah.
some tests.
Oh, I see.
It's back. There's no real right answer. It depends on it's like a risk reward type of scenario. I don't know. I've done it both. I've done it both ways. Both have their pros and cons, right? So it's up to the team basically. But Builder is a pretty cool design pattern, and you get it for free with Lombok. Okay, so now that we have that, what else are we going to cover? We're going to cover entity, right? Okay. Any questions so far? Are we good on all this? You guys ready to put in Lombok into your stuff if you haven't already?